Slope between points is basically the foundation for everything you do with linear functions. And every math class you take, from here until you end at Fairview, you will do something with linear functions. You will be finding slope this year, next year, junior year, and senior year. So if we get this down now, then you're going to just hang out while other kids struggle, because even though this is covered in every math class, it continues to be something that students struggle with. It's attention to detail and requires a little bit of memorization. If we're willing to spend that time now, you don't need to worry about any linear stuff moving forward, okay? But again, linear functions, really important, and it all starts with finding slope, okay? So really one of the more important lessons we have dealt with thus far. I mentioned already that finding slope, likely you have all done at some point already, okay? So what is slope? When we hear the word slope, what does that really mean? It is the ratio of change in y between 2 points to the change in x between those same 2 points, thus giving us one version of it being change in y divided by change in x. It is very common for students to mix that up. They go, oh, is it x divided by y or y divided by x? We need to spend time and effort knowing that it is always change in y divided by change in x. Okay, so that's ultimately what slope means. It is usually represented by the letter m. A lot of you have already said mx plus b, or a little bit ahead of where we're going to get to, but we will talk about mx plus b soon. And then taking this change in y and change in x, it can be represented in different ways. This triangle right here, when you see that math symbol triangle, that's actually the Greek letter delta, and it represents change. Okay, so when you see this triangle or delta y, that's change in y divided by change in x. So this is saying the exact same thing as change in y divided by change in x, just using more specific notation. When we talk about change in y, that tells us how much we have risen. Okay, so you hear change in y as being your rise. And another way to think about slope is rise over run. Okay, so rise being our change in y, run being our change in x. This ultimately brings us to our slope formula, okay, which is, this should be y2, so let's change that. y2 minus y1 over x2 minus x1. This gets used quite frequently, so this is your slope formula. Okay, so knowing all these things, you're going to hear me say these throughout the entire time we worked with linear functions. I'll say change in y divided by change in x. I will say rise over run. I will say y2 minus y1 divided by x2 minus x1. So being familiar with all these forms, it's so important for not only this class, but for future math classes. So again, be willing to spend a little bit of time making sure you know all of these things. Okay, it will go a long ways for your ability to learn math, not just in here, but in future math classes as well. Okay. Now, how we find slope, okay, we're going to do something along these lines, but it all depends on what information we are given. Okay, so we're going to start with a table of values, and our task is to find the slope of the line represented in the table of values below. Well, this is suggesting to us that this is a line, and thus these are linear tables. So let's make a note of that. So if they're linear tables, or if we are given that it is a line or a linear function, then the slope is constant. And what that means is if we take every change in y and divide it by its change in x, it should give us the same value 100% of the time. Since they're telling us, hey, this table is linear, we don't need to check to see if it's constant. That is already a given. Okay, but let's, in this first one, let's pretend that we didn't see this. Okay, we just saw this table on a piece of paper and it said find the slope and prove that it is linear. Well, what we would need to do is figure out a change in y and a change in x. So to go from 8 to 5, I need to subtract 3. And then to go from -6 to -5, I'm adding 1. So this -3, this is your change in y. Okay, this 1, this is your change in x. So right now, if I take change in y divided by change in x, that is negative 3 divided by 1, which is negative 3. So if this table truly represents a linear function, when I do this for all consecutive values, we should get negative 3 every single time. Let's make sure that happens. So going from 5 to 2, I subtract 3. Negative 5 to negative 4, I add 1. Once again, change in y divided by change in x is negative 3. 2 to negative 1, that's negative 3. That's plus 1. Okay, negative 1, negative 4, negative 3. Negative 4 to negative 7 minus 3. And sure enough, we're subtracting 3 every time for that change in y. And for the x's, we're adding 1. So plus 1, plus 1, plus 1. All right, so that was just us pretending that we didn't know it was linear. Now, let's just go through this as if we noticed that it was linear, and we can just do this fairly quickly. Okay, so find the slope of the line. I'm like, okay, I processed that this table represents a linear function. I need to find any change in y divided by change in x. And again, it doesn't matter where you do this. Okay, I could go negative 1 to 7. And I got to think about, am I adding or subtracting? There I'm adding, so that's plus 8. And then 0 to 2, I'm adding 2. So this change in y and change in x gives us a slope of 8 divided by 2, which is 4. And make sure we're writing it. If I write, you should be writing 2. Now let's say you decided to do something somewhat weird. And instead of going from one y value to the next, you're like, you know, I'm going to skip some. I'm going to figure out what is 15 to 31. Well, that change in y now, 15 to 31, what are we adding? 16. And if I take that same jump and go 4 to 8, well, that change in x is plus 4. Well, look what happens when I take that new change in y and divide it by that same change in x. 16 divided by 4 gives me the exact same slope as 4. Okay, so as long as you are correctly identifying the change in y and the corresponding change in x, it doesn't matter how you get there. Okay? So real quick, find the slope of the tables in 3, 4, and 5. It should take you no more than 2 minutes. Ready to go. So with the remaining tables, nothing odd happens. Again, just pick any y values. You always need at least 2 points to be able to find a slope. But again, it doesn't matter which 2 points you use. So with number 3, I just took the top 2 values. To go from negative 7 to 14, I'm adding 21. And to go on those x's, negative 9 to negative 6, I'm adding 3. So my change in y divided by change in x is 21 divided by 3, which is a positive 7. With these values, okay, and some of us, like with the adding and subtracting, we can get the signs confused. That happens quite frequently. Okay, and so if you do need to check the adding and subtracting with a calculator, just make sure you take the bottom number minus the top number. Okay, so like let's say you're like, hey, I'm not exactly seeing how that's 21. Or maybe you feel like that should be minus 21. Well, if you're somebody that needs to use a calculator, which again is perfectly okay, if I take this bottom number of 14 and subtract a negative 7, we're really adding 7, and that gives me a positive 21. Okay, so if you're struggling to find those values of the change in y or change in x, take the bottom number minus whatever that top number is. All right. Last 2 slopes for 4 and 5. Slope for number 4 is negative 1. I got a change in y to be negative 10 and a corresponding change in x to be positive 10. Give me a slope of negative 1. Then for 5, I did 2 values there because I noticed the x values, they're jumping around. So I was adding 4, then adding 1. So I wanted to make sure that I got the same change in y divided by change in x. So 12 divided by 4, that's 3. And then I got another change in y, that's 3. and a corresponding change in x, that's 1. So 3 divided by 1, again 3. All right, questions here? Go ahead and flip this page over. We're just going to be given 2 points. So how does it doesn't? Okay, and really, I don't want it to change. Okay, so I'm going to show us a couple ways of how we can find the slope when given 2 points. Because this is the type of problem that even students in my Algebra 2 class are still getting incorrect. Students in pre-calculus are still getting incorrect. And a lot of it is because they're not keeping track of positives and negatives. So here's the easy way of how we can do this. And this would be considered less formal. Okay, so when we're given 2 points, it's going to be helpful if we label one of them as being x1, y1, and the other being x2, y2. Well, one thing that we can do is turn it into a problem like what we just did. Let's take these 2 points and let's write them in a table. Let's make a quick table here. So x, y, and I'm going to take 5 as one x value. Its corresponding y of negative 14. I'm going to do the same thing with my other point, 11 and 18. Well, now this is the exact same thing as what we did on the previous page. We have a table, and so finding this difference here, that's going to be a change in y, and finding this difference here, that's going to be my change in x. So negative 14 to 18, we are adding, and we'd be adding 32. 5 to 11, we're adding 6. So our change in y divided by change in x is 32 divided by 6. That does not work out to be a whole number. And typically with slope, we want to leave it in its fraction form. Okay, so this could get reduced down. Let's just leave it as 32/6. Might be worth some of us checking to make sure it doesn't divide and to be a nice number. 16/3 is the reduced version, so let's just call that 16/3. It's probably the more simplified way of stating that. And let's do this. Why don't you all do the exact same thing for 8? But I want you to wait on 9 and 10, because 9 and 10 is when I'm going to have us do the more formal way of finding slope. So everyone real quick, just go ahead and find the slope in 8 by putting those values in a table. Still label them as x1, y1, and x2, y2, because that's how we're going to find the slope for 9 and 10. I'll give you 2 minutes to do so. Okay, so putting everything in a table, here the y values stay the same. So your change in y is 0. Right? I'm still going to figure out the change in x, negative 4 to 14, that's adding 18. And thus our slope, change in y divided by change in x, is 0 divided by 18. That is 0. Okay, we can't take 0 and divide it by a number. It will always be 0. Okay, but if that was reversed, okay, if we had 18 divided by 0, that's an undefined slope, and that will show up from time to time. So let's just make a note of that, that if we had 18 divided by 0, that's undefined. And your calculator will tell you that. If you try to do 18 divided by 0, it'll yell at you. Okay, it'll give you some error message saying we can't divide by 0. Okay. So again, that's a little more informal of putting those points into a table. I really like it because it keeps everything the exact same. You don't have to get so caught up in all the signs. However, as you transition into higher level math, you're going to be expected to use the actual slope formula of y2 minus y1 divided by x2 minus x1. Okay, and let's try that right now. When we're labeling our points as x1, y1, and x2, y2, it doesn't matter which one you call which. Okay, either one of these could be x1, y1, or x2, y2. So 19 or negative 19 will be my x1. 0 will be my y1. Let me write that again. So x1, y1. Then x2, y2. So all that we're going to do is we're going to take the number that we label as y2. I'm going to put that in the place of the y2 in the slope formula. So that's 17. And then minus the other y value, so y2 minus y1, which is 0, and divide it by the same thing with my x's. So it has to be the first, or my x2 here. So that's negative 14. And minus, this time it's minus a negative 19. And this is the case where a lot of students will make mistakes because of that double negative showing up. So then 17 minus 0, that's 17. That is our change in y. Okay, so our change in y from one y value to the next is either adding 17, it could even be negative 17. Okay, it doesn't really matter which points x1, y1, and x2, y2. Then negative 14 minus a negative 19 really means that we're adding 19, and that makes us 5. So it is 17/5. Cannot be reduced down any further. That is all that we can get to. Real quick, why don't you all do the same thing? This time, let's switch it up. Let's call this x2, y2, and this x1, y1, and see if you can't plug things into the formula the same way that I just did. See what you come up with. I'll do about 2 minutes again. So based on how I label these points, y2 is negative 8 minus y1 gives us a minus a negative 13. Since we're minusing a negative, that really means we're adding 13 to negative 8, and thus your change in y is 5. x2 is negative 13 minus x1 of being negative 12. Once again, we are adding with the double negatives there. Negative 13 plus 12 is negative 1. And change in y divided by change in x gives us our slope of negative 5. So moving forward, find a way that works for you. If you're like, I'm having a hard time figuring out where these numbers are going, the double negatives throw me off, that's okay. Then use the table. The table, to me, is a much more simple way to find the slope. Again, it's just a little more informal, but it doesn't matter. You just need to find a way that works for you, okay? All right, last thing that we're going to go over is finding slope on a graph. When we're finding slope on a graph, there's lots of ways of how we can do this as well. We could write down the coordinates of both points that are given, or when we're working with a graph, this is where I just simply think of my rise over run. And so what I would do is I'd find 2 points that intersect nicely. Luckily, that's built into this graph already. And I just make a little triangle connecting these points. And I figure out how far over do I need to go from one point to the next. And it doesn't matter where you start, as long as you're consistent. So I'm going to pretend that I'm starting at this bottom point. So from this bottom point, I have to go right 1, 2. So if I'm going right, that is a positive value. So I'm saying that I'm going right to, which is the run. And then from that bottom point, I go right to, and then I have to go up 1. If I go up, that is a positive value. So our rise here is a positive 1. The run is a positive 2. Thus, our slope, rise over run, is a positive 1 divided by 1, 2, which is 1/2. Okay, so with this case, I started with the bottom point and went to the top. This next one, I'm just going to show you that it does not matter where you start. So if you start at the top point and go to the bottom, it's all the same. Okay, so if I go down and then to the right, now my rise, I'm going down 1, 2, 3, 4, 5, 6. So negative 6 is that rise. And I'm running to the right by 2. So the run, positive 2. And thus our slope, negative 6 divided by 2, is negative 3. Look what happens if I reverse that. If instead I go up first and then to the left, well, now my rise is positive 6, and now the run is negative 2. Well, if I take 6 divided by negative 2, that is still negative 3, and it is all the same. Okay, so it doesn't matter what point you start from and where you end with. Just be very thoughtful about what your signs are. Again, up is positive, right is positive, down is negative, left is negative. And take 2 more minutes to find the slopes between 13, 14, and 15. That'll take us right to the end of class. We will check those here in 2 minutes. And that'll be it for today. For just a sec. Shh. In 13, that is a negative slope line. So your slope there is negative 4/5. Again, with slope, keeping it in its fraction form is actually a little bit better. And you'll see that when we actually start graphing lines. So our slope there in rise over run is negative 4 divided by 5. Or 5 divided by negative 4, all the same. 14, same idea, negative 1/3. Or 1 divided by negative 3. And then that last one, 15, I'm noticing the 2 points that I'm given, I'm not having to go over by anything. So the run is 0, but the rise is either 1 or negative 1. So when I take 1 divided by 0, that's where I can't do that. And where the calculator would yell at me and say that is not possible. And thus that slope is undefined. All right, you have 2 homeworks that I will be checking on Friday. Okay, the tables that we started earlier in class, and then this slope homework as well. Answer keys are posted on Schoology just like first semester. Now you can grab phones